All right, so I had a student submit some questions for review, so that's what we're going to do today. I'm going to get my tablet here. Sorry. All right, I'm actually ready now. So I believe some of these questions are from the SAT College Board textbook. So if you have that textbook, you're welcome to follow along. And I'm going to go through these quickly. Do please pause and review and rewatch as necessary. So here we go. Without much further ado. These are all math questions, by the way. I don't know what questions he submitted, so I'm just going to go through them individually. Whenever I see a big wall of text like this guy here, I'm just going to read the last sentence. What is the least value to store can receive for the 11th rating? Still be able to average at least 85 for the first 20 ratings. Okay. The first 10 ratings had an average of 75. So that means that if I take the sum of the first 10 ratings and divide it by 10, then that rating is 75. So I know the sum of the first 10 ratings is 750. There's going to be another 10 ratings, and I want to minimize the 11th rating. If I want to minimize the 11th rating, I'm going to maximize the other 9, which means that they each have a rating of 100. To minimize one thing, you maximize the other. So if there are 750 originally, then we have 9 with maximum rating, and then we have our 1 with the minimum rating. That's going to be 20 items, and we want that to have an average rating of at least 85. So we can just crunch the numbers on that. Get a calculator pulled up here because I believe this is indeed the calculator section, and I'm too lazy to do 20 times 85 in my head. 1700 minus 750 and 900, 1650 is 50. And so I believe the answer for number 35 here is 50. I don't know which test he pulled this from, but I believe that's going to be our correct answer there. And we could, of course, verify it algebraically if we wanted to. The next one here, let's see how blue looks. Oh, yeah. It's the rainbow color. All right, the next one here, what value of k will the system have no solution? The no solution is the indicator here of what we should be doing. If two linear functions, and these are indeed linear functions, have no solution, that means they have the same slope. Always name what kind of function you're working with and identify key terminology. Linear functions have no exponents, and no solution means they have the same slope. In standard form, ax plus by equals c. The slope is equal to negative a over b. So in this equation here, negative 4 over negative 5 is the slope, so of course 4 over 5 is our slope. So we can say, okay, negative k over negative 3, and since is the slope of this one, and since they're supposed to be equal, we set that equal to 4 over 5, and we can solve for k. The negatives, of course, drop off, cross multiply, we get 5k equals 12. I guess we could have just divided. Leave that 5 over there. Don't have to multiply it over, and 12 over 5 is our answer. Next one. Sorry, I'm going quickly because I've got appointments coming in like 15 minutes. Sum of three numbers is 855, so okay, they tell us one of the numbers is x. 50% more than the sum of the other two numbers. So x is equal to 1.5, the sum of the other two. Let's call them a and b. It doesn't matter what you call them. So the sum of x, a, and b is equal to 855. X is 50% more than the other two. So if I have a and b right here, I can substitute this out. Let's manipulate that around. If we divide by 1.5, we get a plus b is equal to x over 1.5. So now I have a plus b here, a plus b here. We can substitute that out. The SAT loves to treat multiple things like it's one thing. So that's what I'm doing here, is I've got x over 1.5 going in for a plus b. So x plus, not a plus b, but what it's equal to, x over 1.5 equals 855. That may look kind of scary, but it really isn't too bad. If you prefer fractions, 1.5 is 3 halves. And to get that to not be a fraction in the denominator, you can multiply by its reciprocal instead, so 2/3. And that's just a general rule that you should try to study and memorize. If you have something divided by a fraction, you can instead multiply by that fraction's reciprocal. And I'll leave that to you to go through the reasoning of it. Do try to think about that. So we could say c over b times a is equivalent to that. So do think about that. So going back here, x plus 2/3 x, or 2x over 3. That's a little simpler to look at. We can get 3 over 3 as a common denominator. So 5/3 x equals 855. And then one of the common tricks here, if this is a no calculator question, I don't know that it is or is not, I didn't see the top of the page, is of course we're going to multiply by the reciprocal here again, times 3 over 5. This cancels completely. We get x equals, a lot of people are going to say, 855 times 3, that's going to waste a lot of time. Well, do the division first then. 8 divided by 5 is 1, with a remainder of 3. 35 nicely does 7, and then 5 does 1. So 171 is 855 divided by 3, and then or divided by 5 rather, and then we multiply by 3. That's a little easier to do. 3 times 100 is 300, times 70 is 210, times 1 is 3. You add those together, you get 513. And that should be our answer. Make sure you rewatch that one and then try to explain it. That one was complicated. The verbalization step is really important, though, if you want to study and memorize this stuff, so try to explain it to somebody else. Big wall of text, jump to the end. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all the people in town? So least and all are keywords that we want to pay attention to. Least likely that a reliable conclusion that all of the people. So they asked 117 people, so that's a good sample size. There's a local restaurant, and 7 people refused to respond. So they only asked the people who visited the local restaurant, and do we care about their sports watching preferences at a restaurant? I think that's a self-selection bias, because people who go to a restaurant may or may not be the type of people who watch sports. Depends on the type of restaurant as well. And if you only sample that restaurant, you can only make generalizations about the population within the restaurant. If I want to make a generalization about all the people in the town, I have to survey a random selection of the population from the town, not from a particular restaurant in town. Okay. You might argue that the restaurant is a representative sample of the town, but you don't know if the people in the restaurant live in that town. And it may be a particular kind of restaurant, so you're only getting the type of people who go to that kind of restaurant. If it's a sports bar, they're more likely to enjoy sports. If it's a fine dining establishment, maybe they are, maybe they aren't the type who enjoy sports. But anyway. Okay. What is the median number of siblings for all the students surveyed? So the median is the middle number. Number of siblings is given here. The number of people in each category is given there. So if I want to do all the students surveyed, so I have to add these rows up. 260, 190, 90, 40, and 20. And median is the middle of everyone. We're only concerned with the survey, so we don't care about this information here. So they asked 300 students, so the median of 300 is going to be the average of the middle two, because it's an even number of terms. If it was odd, just the middle term would be the median. So because it's even, we take the average of the two middle terms. And the middle of 300 is going to be what? 149 and 150, or 150 and 151, one of those pairs. My guess is it's not going to matter. From each of the two schools, so it's 600. So the 300th and the 301st. So there's 260, the 300th and the 301st are going to be in here. And that doesn't matter if you start from the top or the bottom, because you go 20, adding 60, adding to 150, yeah, and again, 300 is going to get crossed in this threshold here. So the median is 1, because the 300th and the 301st and the 299th, they're all 1s. Think of these as positions. Position 1, position 2, position 3, position up through 260 all contain a 0. Position 261 through 351 contain a 1. Positions, the next 90 positions contain a 2. We want to find the median position, and the value in that position is the median value. Okay. Based on the survey data, which is following. So another survey question. These seems to be giving the student some trouble. These were submissions from a student here. So another survey. Remember, surveys are just kind of logic puzzles. Which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? So that's again using this previous data, I suppose. The expected total of students with 4 siblings. So we have to compare that to the total number of students in the school. It's a probability style question, I suppose. At the 2 schools, so 2,400 and 3,300 makes a total of 5,700. And the part that we care about is x, and the part that we care about is the 4. So there were 20 out of 600 that represent the 4 out of the total who were surveyed. Students with 4 siblings out of those who were surveyed equals students with 4 siblings out of those in the schools. Part over total equals part over total. We want to isolate x, so multiply by 5,700 on both sides. And again, reduce before you multiply. X equals, knock off the zeros, and that 20 and 6 can reduce. Divide by 2, so 10 over 3 times 57. 57 is divisible by 3, I think. So divide by 3, that's 1. Divide by 3, that's 19. And 10 times 19 is 190. It's pretty easy. Oh, we didn't even need to solve. Look at the answer choices. The total number of students with 4 siblings is expected to be equal at the 2 schools. No, that's not true because they don't have equal student bodies. The proportions are not equal. 4 siblings is expected to be 30 more than at Washington School. Perhaps. Let's erase all of our math down here. Total number of students with 4 siblings at Washington is expected to be 30 more than Lincoln. Total number of students. So we don't actually have to calculate that because they just flip it. Total number of students with 4 siblings at Washington is expected to be 900 more. So that was only 190 that had 4 siblings at all. So 900 more doesn't make any sense. Between the 2 schools, there are only 190 kids predicted to have 4 siblings. So that's kind of an absurd comparison. So Washington School has the larger population, so it makes sense then that proportionately speaking, Washington is going to have more kids with 30 siblings, but the total proportion here was a smaller percentage. So if we think of it as a percentage of the total population, 10 out of here 300 is a larger, or is the same percentage rather, as 10 out of 300 for the other school. So we're going to apply that same percent to each school, 1/30th. So 1/30th of 2,400 is smaller than 1/30th of 3,300. Assuming this is the calculator part, 1/30th times 2,400 is 80. 1/30th times 3,300 is 110. So indeed, the Washington School has 30 more than Lincoln. So C. We didn't have to calculate it. We could just intuitively know that you take the same percent of a larger number and it's going to result with a larger population. All right, moving on. Radius of the circle, just memorize the equation of the circle, x minus h squared plus y minus k squared equals r squared. There's no shortcut here. You just have to memorize that. H and k is the center, r is the radius, so we have to convert this equation into the standard form of a circle. We have to do something called completing the square. So the first thing is to cluster the like terms together, x squared and 4x, and we're going to leave a blank here. Y squared minus 2y, and again leave a blank, equals negative 1. And we have to fill in this blank spot with completing the square. So divide this by 2, we get 2, square it, and we get 4, and we add that here, and we also add it here, because whatever you add to one side, you have to add to the other. So we add 4. Then we do it again with the y values. Divide that by 2, we get negative 1. Square it, we get 1. Add it back, we get 1 and plus 1. So of course on the right hand side here we get positive 4. And remember that's the radius squared, and if that's the only thing we care about, the square root of that is 2. If we wanted the center of this circle, it's actually going to be the factorization of these, but you could just take these two values here and that's your center, 2, negative 1. Or I think you might have to flip it. Let's see. Factor that, you get x plus 2 squared plus y minus 1 squared. Yeah, you got to flip the sign on it. So it's negative 2, 1 is the center. If they had asked for it. They did not, so we don't really care. I apologize for the dimness on the printouts here. This is just how it was sent to me. All right, moving right along. Another interpretation question. A lot of questions with these big chunky pieces of text. Very little math to actually be done on these. Looking at number 27. 2 samples of water equal mass. You get the big wall of text jump to the end. Which of the following statements correctly compares the average rates at which the temperatures change? So the rates that they change appear to be somewhat similar. The non-insulated drops faster and then levels off quicker compared to the insulated. It decreases more steadily and at a slower rate. So let's see if we have something that says that. Every 10-minute interval, the magnitude of the rate of change in temperature of the insulated is greater than. So the magnitude of the temperature change is the drop from here to here. The vertical drop there is the temperature change. And the temperature change here is clearly much greater than the temperature change here, especially as you compare that first drop. That first drop is much more significant. And it's not true necessarily that in every 10-minute interval the magnitude of the insulated is greater than, because if we compare the tail end here, this one doesn't change very much, probably because it's reached room temperature, whereas this one is continuing to decrease. So it's not true at every point. It's true at the beginning, but not towards the end. So I'm not going to pick A just yet. It may still be A. Every 10-minute interval. Non-insulated is greater. That's just patently false. The intervals from 0 to 10 and 10 to 20 insulated are of greater magnitude. That's just false. And that's false anyway. It was B that's true at the beginning, but not true at the end. And then here, 0 to 10, 10 to 20. So for the first two intervals, the change of the non-insulated is greater magnitude, whereas the other way, the insulated is of greater magnitude. And that's totally what we observed, is that the non-insulated does have a greater drop than this for those first two intervals. Whereas everything after that, the insulated has a greater drop because it has not yet reached room temperature. So it must be D. Be wary of things that speak in absolutes. All, every, none, each. these absolute statements you want to be quite wary of. All right, this one looks like it's going to have some math. Okay. The area of the hexagon is that. What is the area of the square? So it's a regular hexagon, so that means that each side is the same. And it's a square, so that means each side here is the same as well. So if I can find the side length of the hexagon, then I can find the area of the square, because the area of square is just the side length squared. Let's see, the area of a hexagon. We could cut this into two isosceles trapezoids, or we could go even further and cut this into 6 isosceles triangles. That might be the easiest way to go, because they've got the root 3 on there. This is making me think that they're using 30, 60, 90 right triangle properties. So let's zoom in on one of these triangles here. Let's literally just do that since we're on the computer. If we just zoom all the way in, that's as far as it's going to let me. So, zoom out. All right, I lost it. OneNote is great for some things, not super great for others. So let's make one bigger. So if I take this triangle here and say, okay, we know the area of the whole thing is 384 root 3, so we divide that into 6 equal parts. 384 divided by 6 is what? We can drop it by a magnitude of 2 first. So that's 192 over 3. Divided by 3, that's 62, or no. 64, because 3 goes into 19 6 times with a remainder of 1 left over. 3 goes into 12 4 times, so 64 root 3 is the area of one of these triangles. And if we drop an altitude on that triangle, we have to know something about hexagons. Each degree measure on the outside here in a hexagon, in any n-gon, any sided figure, the number of sides times, 180 minus the number of sides times 2 gives you the number of degrees in the whole shape. You divide that by the number of sides, and that gives you the degree measure on each angle, or the number of, so 180, sorry, that is totally wrong. It's 180 times n minus 2. There we go. Had that all mixed up. 180 times 4 divided by 6 tells us that that degree measure is 120. If I cut that in half, which it would be if I draw these lines to the center, then it's 60. And if we cut it in half again, then it's 30. So that's a 30, 60, 90 right triangle. Remember, I was saying that that's going to come into play here because of the area. We know the area is 64 root 3. And remember, the area of a triangle is 1/2 base height. So if this is the base and that's the height, 1/2 base height equals 64 root 3. The height is going to have a root 3 on it. So this is base over 2 because that's the whole length there divided by 2. And on 30, 60, 90 right triangle ratios, again, another thing you have to memorize. There's a lot to memorize here. On 30, that's too far over that way. On 30, 60, 90 right triangles, let's draw it a little bigger. 60, 30, 90. If this is A, this is A root 3, and this is 2A. So all I care about is that 2A, remember. If I can get the side length, we can get the area of the square, which is ultimately our goal. Don't lose sight of that. So this is B over 2. Remember that this side over here is going to be that base B over 2 root 3. Back in. And then this is going to be 2B over 2, so just B, the length of the base. Since we know the area is 64 root 3, and I know that the height now is b over 2 root 3, I can replace that in this equation here. 1/2 b over 2 root 3 equals 64 root 3. We can now start doing some algebra to find that. The root 3's can divide off. Thank goodness, right? I'm going to carry it up to here, or over here rather. We got 1/2 b times, again, 1/2 b or b over 2, it's the same thing. So that ends up being b squared over 4 equals 64. Multiply the 4 over, gets rid of that. And then I can actually square root everything. Everything here has a nice square root before I even do the multiplication. So you get b equals 8 times 2, which is 16. So that side length is 16. And then what? So 16 squared, I guess, because the side length over here is 16. And 16, area of the square, 16 squared times 16, which I don't have memorized. That'd be 160 plus, who knows? I'm too lazy to do that in my head right now. 60 times 16 is 256. I should have known that. All right, and of course, there it is. Getting to the end here. And of course, feel free to pause, rewatch, review, and do take notes as you go through and try to explain these things to yourself. Grab a stuffed animal and explain them to your stuffed animal. It's the best way to learn, is to try to explain. Okay, moving right along. If they ever tell you that something equals a thing, just plug it in. So just right away, 3 equals ax squared plus b. They tell us that it has exactly 2 solutions. That tells us that the discriminant in the quadratic equation, remember the quadratic equation is negative b plus and minus the square root b squared minus 4ac all over 2a. The discriminant is the stuff under the square root, under the radical there. So the discriminant is positive if there are 2 roots. If there's 1 root, it's 0. If it's got no roots or no solutions, then it's negative. So we can say b squared minus 4ac is greater than 0, because we know it has 2 solutions. All right, so I get this in standard form. 0 equals ax squared plus b minus 3. So there's no x term here, so let's get that in there. Ax squared plus 0x plus b minus 3, and this b minus 3 is actually our c value. So a, b is 0, c is b minus 3. Don't let the b's confuse you. In that, the quadratic formula, b is just the placeholder for the coefficient on the x term. Here, in this equation, b is being put into the c value of the standard form. That it can be confusing, but just remember that a, b, and c are arbitrary place value holders. It's the place that matters, not the name of the variable. So b in this scenario is 0. Minus 4a is a. C is, remember, b minus 3. Greater than 0. So negative 4ab, I'm distributing this through now, plus 4 times 3 is 12. 12a is greater than 0. And now can we just plug it in? Can we just plug in answer choices? Is that really the best way to do this? Probably. I don't like this approach that I'm taking. There may be an easier way, but this is the first thing that came to mind. So plugging in negative 2. We know that this needs to be positive, so plugging in negative 2 would make this whole thing positive. Let's go ahead and try that. Well, yeah. Did I mess something up? feel like I messed something up because I get the impression that both A and B would work. Let's go ahead and do it. A is -2, B is 2, so that'd be positive 16 plus, that's negative. So that would actually be minus 24, and indeed that is negative, so that does not satisfy the situation. I see what they're doing here. -2 and 4, so that would be 8 times 4 is 32. Minus 24 again, that stays positive, so that's our answer. C and D wouldn't necessarily do it because that would have a large negative plus something, probably not large enough. So 4 times 2, -8 times 4 is -32 plus 24, yeah, still negative. Plug in 4, -16 times 3, yeah, that's a massive negative number. Plus 48, so yeah, that's still going to be negative. So that ends up being the way to do it. I'm going to keep pondering that one, see if I can think of a easier way to do it, but I don't believe there's going to be. That's probably the best way to do it, thinking of the discriminant. And then the last one we got is a geometry question. That looks like a geometry question. It might not be a geometry question. Let's see. The circumference of the circle is 96, so that's the whole way around. Remember that that's 2 pi r is 96. What is the length of ln? Arc ln. All right. So we can get the radius from that. So the radius is equal to 96 divided by 2 is 48 over pi, because you're dividing the pi over as well. Sure. So 48 over pi here, 48 over pi there. We're going to let that be for a minute. Let's focus on the degree measure. Well, the path forward here, the plan, arc length is equal to the number of degrees that you care about over 360, because it's the part over the total, times the circumference, because that's the total arc length, so 2 pi r. They've already told us that 2 pi r is 96, so the arc length is the degree measure over 360 times 96. So we might not even need the radius in this scenario. Now let's see if we can do it without. So if this is 60 degrees, I believe there's a property in, my board is wigging out here, in geometry that tells us that these angles here should be congruent because these lengths here are congruent and these lengths here are congruent. So this is a kite. And in kites, those two angles should be congruent, and then these should be angle bisectors. And if those are congruent, remember in quadrilaterals, in a kite, the angles add up to 360. So 360 equals these two congruent angles. Oh, do they tell us that these are tangent? This would be so much easier if these are tangent. Ah, yes. Okay. Whew. They do tell us that it's tangent. Always inventory what you're given. All right. These are tangent to the circle. If those are tangent, these are 90-degree angles. And that makes this incredibly easy because, again, quadrilaterals add up to 360. So 360 minus 90 minus 90 minus 60. So that's 180, and 60 is 240. 240 is the sum of L, N, and M. And that should give us angle O here. So that's 120. And so now that we have the angle, we're home free. So the length of the arc equals 120 over 360 times 96. That's 1/3. So 1/3 times 96. Dividing it out, you get 32. And that should be the length of the arc. Doesn't look like it's multiple choice, but there it is. All right, so we've done all of them, I believe. 3, 6, 9, 10, 11 questions. I'm going to go ahead and post this now so that you can review it this weekend. And again, feel free to go back, pause, rewatch, review, look at the answer keys. If I missed anything or messed anything up, let me know in the comments. I'll redo it. And I know I'm not perfect, but I believe all of these should be right. And the important thing, again, remember, is not just to get to the correct answer, but to understand how to get to the correct answer. So make sure that you go through these questions on your own multiple times until they make sense and try to explain them. If you can explain them accurately and thoroughly, then you know that you can confidently do similar items on the real exam. And that's the ultimate point, isn't it?